So in this problem, we'll need to check whether if the 3 points whose position vectors are given are collinear or not. Okay, let us begin. So first what we'll do, we'll consider 3 points. Let's say that the points are point P, point Q, and point R. Then we're also going to consider another point O, which is going to be the origin of some coordinate system. Now, to define the position vector of each of these 3 points P, Q, and R with respect to the origin, we have to draw directed line segments joining the origin and that point, either point P, Q, and R. So here we can define the position vector of point P as OP vector. So that will be equals to, let's say, A vector minus 2B vector plus 3C vector. So here we're going to make this assumption here. Then let's say the position vector of point Q, that's defined by the vector negative 2A vector plus 3B vector plus 2C vector. And then we have the vector OR. The OR vector will be given by negative 8A vector plus 13B vector. Fine. Now, what we'll do, we'll try to join point P and point Q with a directed line segment going from P to Q, and we'll try to find out the value of the vector PQ. So PQ vector in terms of the position vector is defined as OQ vector minus OP vector. Now what is OP vector? The OP vector, OQ vector, we need negative 2A vector added to 3B vector plus 2C vector. And from here we're going to subtract the vector OP. The OP vector, that's A vector minus 2B vector plus 3C vector. Now, when we simplify this, so negative 2A, negative A is going to give us negative 3A vector. Then we have positive 3B plus positive 2B, so that's going to be positive 5B vector. And then we have 2C vector minus 3C vector, so that's going to be negative C vector. We're going to label this as number 1, so this is the vector PQ. Next, what we'll do, we're going to find out the vector QR. So that means we have a vector going from point Q to R. So QR vector, in terms of the position vector, it's simply defined by taking OR vector and from here subtracting OQ vector. So what is OR vector? So that's negative 8A vector plus 13B vector. And from here we are subtracting OQ vector. So we're going to get positive 2A vector minus 3B vector minus 2C vector. So that means QR vector is now going to be negative 8A vector plus 2A vector, so that's negative 6A vector. Positive 13B vector minus 3B vector was going to be positive 10B vector. And then we have only negative 2C vector. However, we can take 2 as the common vector. So we have 2 times negative 3A vector plus 5B vector minus C vector, which is actually the vector PQ, this particular vector. So that means here we have, since we have QR vector equals to 2 times the vector PQ, where 2 being a scalar, this simply tells us that point P, Q, and R are collinear. It must be collinear. Only then we can express the vector QR in terms of PQ. All we have to do is multiply it with some scalar which has a value of 2.